So again, my name is Johan, and I'm gonna talk about the network architecture. Well, I'm gonna start with the timeline because I think just to see where we are, I think I already introduced the current state of the community in the Kickstarter campaign. From a technological view, what we did in July was we validated some basic connectivity and routing, and for the launching conference in August, we developed a demonstration setup with some basic routing, just to show people that it works, to demonstrate the water sensor and everything. And actually, it's still the software that we still run in the background in the server is still the demonstration software that we use in the conference. We didn't make a lot of changes there. It's not very stable, but it still works. And we also have an API that we will keep backward compatible. So in September we started to gather, feedback from experts and the experienced community members. And now today, in the last weeks actually, we came up with, well, today I'm going to present it. In the last weeks we had meetings with skilled people from the community, also outside the community, to see what the network architecture should look like. Because it's not as easy as I thought it would be in the beginning. Especially, I will present it later, because of the design principles that we chose. It's not the easiest way out. And from here, we're going to implement it and we're going to test the components. So the design principles. First one is really important. We want to be fully compliant with the LoRa 1, 1.0 and 1.1 specification. We want to support both personalization and over-the-air activation from the start. And actually we are preferring over-the-air activation because that is where the scale is. As Winky introduced also, as one of the principles of the Things Network in general, is that we don't want to have a single point of control. So we're come up with a decentralized architecture. We are supporting geographical segmentation, not only to introduce scaling and decentralization, but also to keep the data as close to the nodes and or to the application as possible. And we want to do the routing as efficient as possible, so by reducing bandwidth, the computations, and the packet drop rate. So then for both the gateway owners who buy the gateway and who share their internet connection, and also for the application developers that develop their application and they want to get the data, we work with a trust-based model where both the gateway owners can connect to the parties they trust, and the application developers, they get the data from the parties they trust. So it's not a model where the data flows from the gateway to the application, or where the application gets all the data from the nodes. There is as I will present, a broker in between, where the trust basically comes together. The security aspects are that we are supporting different network session key for every node. It's also mandatory, by the way, for over-the-air activation, but also for personalization is optional, that we will support. And the application key, which is the secret, basically, will remain secret to the application developers.
Just a remark, maybe you explain to people here what personalization and over-the-air activation means, because I don't think that everybody knows that.
Yeah, alright, so personalization is that you as a thing developer, you hardcode in the device the address and the two keys, the application key and the network key. So there's not really a session, it has a static address and a static application session key and a static network key. And over-the-air activation is different. In the device you only have a longer application ID and a longer device ID, which both are unique. At least the device ID is globally unique and the application ID belongs to one single application. And it basically activates over the network. So it's over-the-air activation, so it sends out a join request, and then the network responds with an accept or a non-accept or whatever, and it gets a temporary address. So the key difference is that in the personalization approach, the thing has an IP address, like a static IP address, and in over-the-air activation it's more like a DHCP approach where the thing gets a dynamic address.
So is it like each thing would talk to one gateway?
No, I will present that as well, because we work with segments. So within a segment, they can move within a segment, and segments are overlapping. When over-the-air activation is used, nodes have to rejoin when they move from one segment to another segment that is not connected. But the rejoin procedure is part of the LoRa protocol. I will get back to that.
Okay.
Yeah. So the core components, essentially, so the gateway, I think that makes sense what a gateway is. And then the application in the bottom right is the user application or platform or whatever the application developer wants to use. And all the colored things are the components that we as the Things Network propose to develop. The state of this proposal in general is more like a request for comments document, so I'm just presenting it here as the idea that we have and we got from the community. It's not final, there are no final decisions made. I invite you all to review this and give me feedback. So we have these components are also part of the architecture that I will present in a few sheets. So the R is the router. Router gets the data from the gateway, sends it to the broker. The broker basically decouples the router and the handler, and that is where the trust comes together, as I just introduced. Then we have a network server. It's essential for LoRa connections. It's to control the data rate of the nodes and to keep track of the frequencies that are used for the nodes, and also to assign addresses for over-the-air activation. Then we have the handler, and the handler acts on behalf of the application. And then we have the application in the bottom right. First thing is the application registration. And that is, it's very simple. It's just you have an application and you want to make use of the Things Network. What do you do? So on the left you have the gateways and the things, and you see there's some overlap. And on the right you see a broker, a handler, and an application. Is this font size, is that readable? No? It says app key. The application, it trusts the handler. The handler can be part of the application, can be integrated, can also be a hosted service. But the handler is the component that needs to have the secret application key. And what it essentially does is it sends it to the broker. I will also publish these sheets for you guys to review. But it basically says to the broker, hey, this is my unique ID. You don't get my application key, but this is the application EUI. That's my unique application ID that I work with. And I also provide you with all the nodes that I have personalized. So like I said, you have nodes with static addresses, and you just have to tell the broker, this is the list and these are the network keys that belong. So then the broker, it has a database with the nodes, and it contains the segment, which is not applicable in personalization. Segments, I will get back to that later. And it has the addresses of the nodes and their session keys. So the network keys are here, and the application key is there. And again, this is initiated from the application. So we will, as the Things Network Foundation, we will host a broker, but since these are open source components, everybody can set up a broker infrastructure. So everybody has an application, you can choose whether to to connect to the Things Network Foundation hosted broker or some other community-driven broker or commercial broker or whatever. Gateway setup. So in the gateways on the left, they have a unique address, and we also replace them in segments. So what you see here is this is S1 and S2 it says, and S1 is bold and it's the primary segment. So this is basically S1, S2, S3. There will not be, this is not realistic in terms of the segments will be very big. It could be that the Netherlands is one segment and Germany is a segment and Poland is another segment, for example. It really depends on the usage of the network and the capacity. But the idea is that a gateway is always part of a geographical segment, and we can assign a segment based on the GPS location, or we can pre-configure it. The segment is important to make the network scalable, because the address space is local to a specific segment or the neighboring segments. So this gateway, for example, it says, yeah, this is segment 2, but I know that segment 1 and segment 3 are close and they act as a secondary segment. Then we have the router, and the gateways are configured with a router, and the gateway owners, they can configure in their gateways where they send the data to, and the data is sent to a router. So the gateway owners, it's their internet connection, they just configure the addresses of routers, they can change it. The Things Gateway that we are selling on Kickstarter is going to be pre-configured with our default hosted router. Everybody can change that, everybody can set up their own router to create a private network. And a router connects to a broker.
May I ask a question?
Yeah.
Just to get this clear, the
Yeah.
router is in the neighborhood geographically of these gateways?
That could be. Yeah, that could be. Is not necessarily.
I understand it's not necessary, but is it something you encourage? Because then the communication times are not too long.
Yeah. Yeah, for locality, it's very important to as I said in the introduction, also to keep the data as close to the application and to the node as possible.
Yeah.
If there is a node and an application in South America, then you would prefer to have a router there, otherwise it's going to be in the ocean, everything. Yes. We also have to deal with the response times in LoRa 1, because the first receive window, for example, when you have a join request from a node, if a node wants to join the network, it basically expects exactly 1 second after sending the join request an accept message, for example. So the whole network has to respond in 1 second. There will be another window a few seconds later, but still it has to be really fast. So for latency, for scalability and everything, we want to keep the routers as close as possible. Routers, they connect to brokers, and in the beginning this will be pre-configured, so the routers, they just have a list of brokers, but we want to implement some network discovery later, some service discovery where routers discover brokers, for example through a peer-to-peer tracking mechanism. So that is to be developed. We're also thinking how we could make this even more decentralized, for example by using blockchain technology. But again, for now we use pre-configured lists, and also the router can also be set up by the community and the broker also.
One quick question.
Yeah.
The communication between different nodes, what are the protocols? So I understand that protocols between the router and the Internet of Things is LoRaWAN, but starting from router to broker, it's all Internet protocols.
Yes. Yeah. So this is LoRa. This is wireless. From here it's Internet. The protocol that's used here is we support the default UDP protocol. that is the open source packet forwarder that is considered the standard that runs on the gateways, is something we support in the router. So it's like a UDP protocol. And from there, this is a custom protocol. I will explain it also. We haven't found, I didn't do a lot of investigation yet, but we didn't find a standard for it yet. And from here, I will get back to that later as well, but those are higher level application protocols. So that could be, for example, MQTT or a WebSocket stream or whatever. Well, like I said, it could be multiple brokers, and routers as they discover brokers or as they are configured with multiple destinations. They have different endpoints, and this is also true for routers. Gateways can be configured with multiple routers, thanks to Ruud's efforts also to have the forwarder. It's a forwarder that sends data not only to one router, but can start it already from the gateway to multiple routers. And this gateway, for example, it sends the data to two routers. Could be a private network, could be another community-driven network, or a closed corporate network. And these routers, they also discover brokers. So this is how we essentially route the data, and this is the gateway setup. So then packet routing, it's the key use case, of course. So we start with this map again with gateways on the left and one router and a few brokers, a handler and an application. And for example, if you have a node here and it has an address, this address could be either obtained from over-the-air activation or a personalized hard-coded address. It doesn't really matter. And it sends data to the gateway, and the gateway sends it to a router. And what you see here is three things, basically. It's the segments where the data comes from, and it says here in blue it's S1 and S2, that's the segment of the gateway. It has the device address. Nobody can read this, not even I can read it, but I know it's there because I created the sheet. And the payload. And the payload is encrypted. So it sends not only payload but also some metadata, where it comes from which segment, and what the device address is of the node. But since this node is also in reach of this gateway, which has different segments, it's also picked up by the other gateway, and it may be configured with the same router. So it sends almost the same packet also to the same router. The only difference being that the segments are different.
So who is going to send the acknowledgements?
Sorry?
Who is going to send the acknowledgement?
The acknowledgement of the packets.
Yeah.
I will get back to that. Yeah. So what the router then does is it's gonna access its local cache to see if it knows which broker is able to handle the data for this specific device address in this specific segment. And both the segment and the device addresses are important because device addresses are unique or scattered within segments. It may very well be that we have a collision, that there are multiple device addresses, multiple nodes using the same device address. That's not really a problem with LoRa. Unlike the internet, for example, where you would have a problem. But in LoRa, you can have multiple nodes using the same device address. The way to find out is basically to try to decrypt the data, and you will see whether the CRC, it's called the MIC, the message integrity check, is correct. Ideally you would want to avoid that because that's just a waste of CPU cycles. But this is on the server, so it doesn't really matter. You can never avoid this, that it happens, but you can only do a best effort to avoid that. So what it does is the router, it asks to the broker, if it doesn't know the device address in this specific segment, then it just asks the broker, hey, can you handle this message in this specific segment? And the broker, it answers. For example, you have this broker, it says yes, I can handle it, and the other one says no. And then the cache of the router is updated, so next time it receives packets from the same device address, from the same segment, it knows already that this broker can handle it. So the other broker, it basically, it's not interesting anymore, so we leave it, and the packet is sent to that broker. But since the packet was received twice, the same packet, the other packet is sent to the broker as well. And so we have two of them, and they are important because for geolocalization, for example, you need a lot of packets from the same node. 3 or 4 or 5 or 6 is best to do the triangulation. So these packets are all preserved, and it essentially sends it to the handler, and the handler does, like I said, the encryption, because the handler is not the only one who has the application key. So again, this is the handler acts on behalf of the application, can be integrated in the application. This is the one who has the application key, so it can decrypt the data, it can do the deduplication, and if it has multiple messages from the same messages received from different gateways, like this one, like 2 is not enough for geolocalization, but it could do geolocalization there. And so what it gets eventually is the metadata and the decrypted payload in an application-specific or a format that is not really dependent on LoRa anymore. So it's decoupling from LoRa to the application there.
So for the triangulation,
yeah.
I reckon you need signal strength as well, right? Then a package.
Yeah.
So you'll send it as well.
Yeah. We send. Yeah. This is a very simplified view, but we send the radio properties also when the message is received. Yeah.
All right. So if your device sends signals, gets picked up by multiple gateways, gets handed onto multiple routers, handed onto multiple brokers, it's then a single. It's the H where everything goes back together, and that's a unique one for each.
For each application. Yeah.
Okay,
for
so
each
that's where everything
application.
goes. Okay.
Yeah. The idea is that the application has one handler. That's just the application handler, and it uses normally one broker, but it could have like an active standby to another broker, and the broker is the one he trusts to get the data from. And the data can be routed to, in this scenario, for example, when there are multiple brokers, it could also be that if this is an active standby broker, that this broker also says yes, and then the data is also sent to that.
Yeah,
broker.
or I was thinking goes by a different router to a different broker.
Yeah.
And then
Yeah.
But then they have
the handler is unique. It's like what I'm saying. That's where everything runs together.
Because it has a key.
Yeah.
There's only one handler that has a key.
Yeah.
Okay.
Yeah.
But if it goes through two brokers, then it gets everything twice, right?
Yeah. Yeah, that could be for redundancy backup. Yeah.
Suppose the Kickstarter is highly successful, which I reckon it will be. You know, like 100 gateways in the vicinity of one node.
Yeah.
Probably in the same segment.
Yeah.
So at some point.
Very accurate localization.
True, true. That's a good thing.
Yeah. No, we need it. Yeah.
Yeah. Of course, the packets are pretty small, but there's a lot of packages going around.
Yeah.
It's just one signal for one node.
Between the routers and the broker, you'd have 100 times.
Yeah. So then it's very important to do this in an efficient manner. So the router ideally knows which broker can handle the message, and if it doesn't know it, then it's going to discover which broker is able to handle it. So this is going to be the router shouldn't broadcast the message to all the brokers it knows. So it has to do some smart things there.
Is there any mechanism to persist the packet data on the router and also on the broker level? So, for example, if things goes down, or you want to keep track of the history of packets received and those kind of things?
Yeah, I think that like a short-term memory is good to have. Yeah, but it's the permanent data store that would be a different thing to do.
But it's only the memory of a physical device. That's it. All the packet information received is only in the memory of a physical device. So the moment it's disconnected, it goes away.
Yeah.
So there is no permanent track of the history of all the communication.
That is that would be in the log files, of course, where the router and the handler and the broker.
Okay, so there are log files.
Log files, yeah, sure, yeah. But of course, it could also dump the raw data to disk. Yeah.
Okay.
Yeah.
The broker will be the place where if you want, store the data. For example, data comes in, your handler is not.
Yeah.
The router will not store anything.
No.
It will just go to the broker and go, okay, I have the capabilities to store or not.
Yeah.
It's up to you, the broker implementation.
Yeah.
But if you have a broker that is able to do that, that would be the place to store it. So that the handler can later say, okay, now I'm back again, I'm ready to take the data now.
Yes.
And of course you can say as a broker provider, I keep your data maximum 15 minutes, and then because I get so many data, then you're done. Yeah, you have, that every broker can decide for himself.
Okay. So it's not really at the level of the router, but more of a broker.
Yeah, the router has to be, clean as possible, because he has to be open for all these gateways.
And it needs to be performant.
Excuse me?
It needs to be performant.
Yes. Yes.
Yeah, it all needs to be performant. Yeah.
Yes, it all needs to be performant, but especially this router, yes. Yeah.
So the activation, so the over-the-air activation, is it's almost the same. That's why I put it in this order. So again, this is like the first sheet is the application that registers to the broker. So it says this is my unique application ID. So it's unique. And then you have a node, for example, again, this one, for example, who sends out a join request. It's part of the software that runs on the node. And it essentially says, hey, I want to join the network. This is the app EUI that I am configured for, and this is my globally unique device EUI. So that is the 8-byte one, the longer one. And I want to join the network, and the gateway says it adds to this that the primary segment is S1, because that is the primary segment of this specific gateway. But then you would have also the same join request from another gateway, because it's in an overlapping area, and it's from segment 2, the same app EUI and def EUI. And then the router essentially asks the same question to the broker, but then not for a device address in a segment, but more like for an application EUI. Do you work for this app EUI that the node wants to join the network for? And here you can see the app has registered its app EUI, and the broker can respond easily by just saying yes, and it's the same. Then we have our LoRa network server, which is required to handle data rate, frequencies, and handling and sending MAC commands. It's part of the LoRaWAN protocol. It's a bit too technical for now, maybe. So this is the broker. This is something we have to discuss still, but somehow it has to come up with a temporary device address for over-the-air activation. So this is like the dynamic addressing part. And a device address is local to a segment. We can do two things. We can just have an addressing server that allocates an address incrementally, and once it reaches the maximum, it starts from 0 again. So you would have collisions, but that's fine. You just filter them out by doing the message integrity check and trying to decrypt the data. You can also just do it randomly, because if you already accept that that there will be collisions in your network, and you can also just assign an address randomly for a segment. And then the broker says to the handler, hey, do you accept this device? And if so, then please sign the accept message with the application key, because the application key still stays here, and it gets a network session key. And then from here, it only has to send back the join accept. And now the node has this temporary device address, and it just can communicate over your network. Now, if it moves to another segment, if it's in a neighboring segment to, for example, it has this join accept is sent to S1, could be also S2. Really depends on the strength of this specific gateway. So if the signal to this gateway is stronger, then that specific gateway gets the command to send the join request to the node. But if this node moves to this segment and it's out of reach from S1, then you see here that this gateway knows that S1 is neighboring segment, so it still works. But if the node would move here, and this could be, like I said, this could be Netherlands, Germany, and Poland, then it has to do a rejoin procedure. And then it would move to a different address space. And that is how we do handle the scaling and the limited address allocation of the LoRaWAN protocol. Then we have another one. I think it's the final one. Yeah, network management. Yeah, it's basically in LoRa you have two types of messages. Basically, one is for the network itself. It's called the MAC commands, and the other one is application payload. And the broker could easily see based on the type of the message whether it is a MAC command or application payload. And if it's a MAC command, it goes to network server. Otherwise, it's application payload. For two-way connections, that's one of the questions, and very important feature of LoRa is that you can also send data back to the node. The application can just send data to the handler can say to the broker, hey, you have to send some data, but then the broker has to know what the gateway is, where the node is nearby to, so it has to keep some state there. And it has to know the data rate and the frequency to send the data to. So this is where the broker basically asks the network server, hey, give me the gateway and the frequency and the data rate. And then it replies and it sends it to the router and then to the right gateway that it has last seen. So that is basically the flows. Then one very important thing, we get a lot of questions about how do we get the data, what are the options.
I just asked previously, the
Yeah.
network server,
Yeah.
who runs it? What is it?
Well, these are logical
I understand.
components, so it doesn't have to be a physical component. I think in our meeting yesterday, we actually said, well, the broker and the network server could be one component as well.
Okay.
But what is important is that there is a node has one specific network server that controls this node. So there's one for every node. There is a network server, like who knows the data rate and the frequency of this specific node. And it's who it runs. It could also be a community, but we host it as part of the
No, but
program.
I mean, because we had nodes speaking to multiple gateways, sending messages to multiple routers, and then possibly multiple brokers.
Yeah.
If they would still need to agree on one.
That's right. That's right. Yeah. And that's one of the open ends. For now, we say that the handler, as it chooses the broker, it implicitly chooses the network server. Yeah. But if there would be multiple brokers here, like in the previous scenario, like when the broker has an active standby, then it has to share the network server. Okay. Or it has to choose a network server. Or what could also be possible is that the handler talks directly to the network server. So it has multiple brokers for standby, and it would have one network server that remains the state of the node.
may remark here for your question. This is where you see that this LoRaWAN protocol is written with telco glasses on. Yeah, the node is controlled by one network server. So you subscribe your node and you pay off your money. Yeah. If we would have designed it ourselves, I would never have chosen a network server that is in control of the node. I would leave that up to the node or up to your handler, but not go in between and say I own this node.
No, but that's true. But the application server can still choose a network server, and it's not that we as a foundation say you have to use one network server. That's different from the telecom provider.
Yeah.
But the fact that there is some central thing that remains state of a node, that is a telco thing. Yeah.
That's what I meant.
Yeah, absolutely. Yeah. So the application and cloud platform integrations, we have different offerings. The first one is where you would have the simple thing, as I introduced in the sheet before, where you would have a broker handler application, and you could also, yeah, red is green, the colors are screwed up, but Node-RED is, people, maybe some of you have heard of it. Who knows what Node-RED is? Alright, so Node-RED is it's like a drag and drop interface. It's like a web application where you can drag and drop your logic, how you want to deal with data. So, for example, on the left you would have incoming data, and then you can have switch statements or functions or call a web service, or if the temperature is below 20 degrees, then post a tweet, for example. Those are the things you can develop in Node-RED, and it makes it very accessible for non-programmers to work with Internet of Things data. And so we want to use that as well in the hosted environment. You can also work with the platform. For example, Amazon Web Services announced the Internet of Things platform. You have Bluemix, Fireware, and you can also, as an application developer, you can also integrate all the handler logic in your application by developing everything yourself or reusing the reference implementation that we come up with. So there are a few offerings. Apart from this, there is also the fact that you can choose whether you want to have the broker and the handler hosted by the foundation, or you want to host everything yourself to keep control of everything.
Is this all hypothesis, or is there already proof of concepts working?
The proof of concept that we have working is only this one.
Okay.
With the broker and the handler being the same component. So we're going to split it, and we will offer the other things as well. But we basically start from scratch with the code and reusing components that we already did for the conference version that we demonstrated in August.
Mm-hmm.
Yeah.
So the currently broker and handler in a test phase is the same piece of software.
Yeah.
But logically very separate.
Yeah. Yeah. So the next steps are, well, we're gonna publish this with a bit more detail in the document and put it online, so you can all read it through. Also the presentation, and like I said, it's in RFC version, so any comments are welcome.
Is there a deadline for that?
Well, yeah, it's not really. I think we can. I want to have it like finalized by the end of this month, but still, it's like a living project. So any changes can possibly be welcome. Yeah, and I exactly.
What should I do if I want to participate in a proof of concept in the Bluemix? From node gateway until...
Yeah, next sheet.
Before you go there,
Yeah.
one other question. So what I could see is, did you think about service providers who could help people to get off the ground with implementing this for themselves?
Yeah.
And where would they sit in your previous picture? Because I wasn't paying fully attention then, I guess. You had 4 lines, yeah? Was that the P?
Yeah.
Okay. So the application would talk to Amazon, so to say, and Amazon would have the handler.
Yeah.
Okay.
Yeah.
Okay, thanks.
It could be hosted, so if you have everything hosted by the foundation, so we will come up with a hosted version. This will this will depend on of course the number of messages will somewhere be limited, or it's going to be fair use policy or whatever. It will also depend on the funding we get. But there will be a hosted offering, and in here, for example, if the broker and handler is hosted, then the platform, of course, it's also hosted. This Amazon Web Services, Bluemix. So you would only this could actually be an app on your phone that talks directly to Bluemix.
Yeah.
So you don't have to have any infrastructure. You just have your node in your phone, and you don't need your own application at all. So one of the other things is to form the development teams and start the implementation. And I want to start with weekly updates on the technical part. So I was thinking about having at least 3 like teams. And it shouldn't be very strict teams, but it should be like groups where you would actually be a member of, or you're not a member of it. That's basically the thing. And if you're a member, then we would have 1 or 2 or multiple channels on Slack, and we would have to have people really involved in the development. For example, have meetings, but it can also be working with people who work remote. One of the guys that are in this network, for example, in the second team is in San Francisco now, so there's a lot of remote working as well. So the first one would be people that develop more on the network access level, so it's the gateway firmwares and the nodes. Then we have the core as I presented, so those are development of the router, broker, network server, and the handler. And the third one is more like working on integration, so it would be the Node-RED things, or even building use cases, integrations with existing cloud platforms, and things like that. And also the getting it ready and bundling and containerized. So yeah, that's my presentation. Is there any questions that people that have any questions?
My advice, include on this slide how to participate, who to contact.
Yeah, well, you can contact me directly. I will.
Or add your name and contact.
Yeah, I will. Yeah, I will. Yeah. Good job. All right, thanks. Yeah. So next steps.
Well, how can we do next steps? That's the most thing we want to know, I think.
Yeah. So I will. You can sign up to if you're part of the mailing list already. Are you?
I've been added, but I haven't seen any mail coming in. So.
Oh, okay. That is one of the channels how we contact the community. So that is the way we will contact you. You can also go to our GitHub. My email address is there. By the way, my email address is johan@thethingsnetwork.org. Or you can talk to me after this presentation.
Can you say something about the Golang? Is this it's a language?
Yeah, it's a language. Yeah, it's Go is
from Google.
Yeah, it's it's a Google sponsored language. Yeah, it's designed by Google engineers, and Golang is designed specifically for long-running microservices. So services that long-running and have very specific tasks. So it shouldn't be no user interfaces, no computer games, it's very specific. It's a compiled language. It's native. It compiles directly to Linux, Windows, Mac, and it's fast and it's very easy to learn. I have a C# background, and I learned this in 2 weeks. And it's very easy to learn for people that have all kinds of backgrounds, like C++ or Java, or even Pascal or Ruby. A lot of principles come together in Go. So I invite you to do a tutorial, and it's really cool. Yeah. All right. I think Wink and I will hang around for I don't know, 20 minutes, half an hour.
Yeah. Yeah, and we still have right now the multi-tech and the M.dot development board. And for multi-tech, they said, I don't know how like some of you guys feel about it, but they said that this development environment is quite easy. It's easy to make a small prototype. So we have 3 development, M.dot development boards. We have multi-tech. I think multi-tech just provided us with software.
I had a call last night with one of their engineers, and the multi-tech comes in different versions. You have the Node-RED version, which is has a Node-RED handler on the gateway, and it's more used for private network, and then you have to do the decryption on the gateway as well. Not really suitable for the Things network. The mLinux version is an open version. You can just install a packet forwarder on it. They have instructions on the website. You only have to change the URL to send the data to the demonstration version of the Things network, and then you get the data from the API. And it works. So we have data coming in from Minneapolis as well. So, and the kit is here.
Yeah. So and because then that's the multi-tech, what the M.dot. That will be interesting. I think that's the most easy way to prototype now. I don't know how you feel about this. Right?
Yeah.
And that's, so they are here to use. And,
all right.
Cool.